Hi guys, so we are in the chapter of linear programming and this is video number 7. As part of the previous video, we understood what is linear programming. We also understood that in objective function, the constraints and the non-negativity constraints together make the linear programming problem. Okay, now it is time to encounter some examples where we will be formulating the linear programming problem. Now see, we have entered the second part of the chapter already as per the snapshot. If you have not seen it, watch the video. You will understand that this chapter is divided essentially into two parts and we are currently in the second part. Okay, so linear programming problems में enter करते ही आपके पास further there are two branches. Number one is where you learn to formulate the problem. So that's where you get a word problem and then you convert it into a system of linear inequalities and the objective function. And the second part is where the system of inequalities is already available, the objective function is also there, you try to solve it. And then there can be a problem where you can be asked to do both of it. So it starts with the word problem, you convert it into the system of inequalities now called as the LPP, and then you solve it. Okay, so in this video let's understand what are the essential steps that you will follow to convert the word problem into an LPP, that is formulation of an LPP. Well, there is a short 6-step process that you will follow. It's very easy and it is the standard process that you will follow throughout the sums. Okay, so I'll read out what is the step and I'll try to take a relevant example so that you can understand or you can relate. Okay, the first step is the identification that what is the purpose of this sum, whether you have been asked to maximize anything or you have been asked to minimize anything. A very layman example hai, any shopkeeper will always try to maximize the profit. Any person will always try to minimize the household expenditure. So such things are very related. Okay, आप कभी भी profit minimize नहीं करते हो, ना कि आप कभी cost को maximize करोगे. So for standard sums, it is understood that the profit is to be maximized, the cost is to be minimized. There can be some non-standard sums, like for example, I am traveling and I am covering a particular distance. So the question might be to cover the maximum distance. So that is a sum where again there will be maximize. Okay, so these kind of scenarios, okay, will be in front of you, and your first job is to identify कि मुझे करना क्या है, maximize या minimize. That's the first thing. Having done that, so this is all, I have read the problem and I have absorbed कि मुझे maximize करना है या minimize करना है. And second thing is I will assume the decision variables x and y. You have done this as part of your word problems in 11th in linear equations and in quadratics, where you assume let the two numbers be x and y. Example more so relevant with this chapter would be let the number of tables be x and number of chairs be y. Something like this to start with, where now you have got your decision variables and you have termed it as x and y. So I have already determined कि मुझे maximize करना है या minimize करना है, and I have also decided कि what is going to be x and what is going to be y. Let's see next. Form the objective function as a mathematical expression of x and y, term it as z. So we know that the objective function is what you are trying to maximize or minimize. So अगर example आप profit को maximize कर रहे हो तो convert the statement of profit into a mathematical expression. Suppose that the number of tables is represented as x. Profit on one table is 1000 rupees. So the total profit on tables is 1000x. Profit on a chair is 500. You already took chairs as y, so it is 500y. So 1000x plus 500y is what is going to be your objective function. You will write this as z. Z equal to. So यहाँ तक हमारा 3 steps complete हो गया. I have identified the objective function also, right? Next, अभी आपको inequations लिखने हैं, तो you have to look for the constraints. convert them into linear inequations. The advantage here, we'll only get sums wherein we have two variables. We'll not get any question wherein there will be three variables, so we are sticking to x and y, and therefore from the beginning we are just mentioning x and y. Constraints can be, however, multiple. They can be 2, 3, 4. What is the normal standard that we expect in the exam is 2 to 4 problems, 2 to 4 constraints can be part of your question. Okay, next we have to look for hidden conditions including the non-negativity constraints. See, no one tells you about the non-negativity constraints, you are the one who puts them in the sum. So we have the constraints, okay, and after that we have finished the problem. अपने problems में से constraints निकाल दिए. Now you will write the non-negativity constraints, that is x greater than 0, y greater than equal to 0, and look for other constraints also. For example, there might be a very small line somewhere in the question saying that the raw material or the amount of food that is available is sufficient enough for just 400 tables. So then in that case you cannot make more than 400 tables, so your x has to be less than equal to 400. So these single variable constraints are a little hidden, and normally we miss out on identifying them in the question. It will lead to a different answer. So make sure you look and you identify those constraints and also mention the non-negativity constraints. Next, the final step, that is to express the LPP in a particular format. This is how it looks. Maximize ho ya minimize ho, that z equal to, alright, subject to. So based on these constraints this will be done. a1x plus b1y less than equal to c1, and so on, all of your constraints, okay, as many as they are, and finally non-negativity constraints of x and y greater than equal to 0. So based on these steps we will be solving some problems. Try to follow. See, it's a very good template for you to follow, and this will make sure that you are able to convert maximum of the problems very easily into the LPP, and then later on solve them if asked. But other than going randomly, follow this process. It is going to really be helpful in fast forwarding your learning for conversion of word problems into LPP. Let's take a few examples.